All right, for the last video of Notes 22, we've got a couple systems to solve. Now, I already recognize that both of these systems are well set up to do substitution. In problem number 8 here, I know what x is equal to, so I can replace x. And in problem number 9, yes, I'm looking ahead, that one tells me what y is equal to, so I do that substitution. So let's start with number 8 here. I've already kind of highlighted what I know. Right? We know what x is equal to. It says 2y plus 3. So instead of x in the second equation, I am going to substitute. I'm going to replace it. Again, it's a descriptive word for what you're doing to solve. So 2, I'm going to leave my space for x, minus 3y equals 9. Don't change any of the rest of the problem, right? There's my 2, minus 3y equals to 9. Nothing else changed, but now we're going to replace x with what it equals. So 2y plus 3. This equation now just has the variable y in it, and we are going to solve for y. All right, so 4y plus 6 minus, that is a horrible 3. Try that again. There we go. 3y equals 9. Okay, 4y minus 3y would be y. 1y if it makes you happy. Plus 6 equals 9, so I'm going to subtract 6 from both sides. And lo and behold, y is equal to 3. Fabulous, wonderful, you are not done. So as we talked about before, a system is, in this case, a pair of equations, and we are looking for where they intersect. What is the common point that makes both of these equations true at the same time? And in this case, I now know that common point has a y value of 3, but I also need to know what the x value is. So I'm going to take this value for y, put it back into one of the two originals. Does it matter which one? Not really. I'm just going to go with which one I think is easier, which is going to be the top one. So x equals 2 times, give myself a little space for what y equals. That is a 3 there. So x equals 6 plus 3, and I'm getting 9 for my x value. So let's see here. Yep, that looks good. All right, so we have a system of equations. We figured out the ordered pair where they intersect, and that is the end of problem number 8. I'm going to go ahead and repeat the process for question number 9. Now, in question number 9, I know what y is equal to, right? Clearly, it says y equals this, so I'm going to replace y. So starting with that top equation, 2x plus 4y, just leave myself a space for y, equals 28. And I'm going to replace y with what we said it was equal to, which is x minus 5. And now this equation only has x in it. I'm going to go ahead and solve that. All right, so 2x plus 4x minus 20 equals 28. 2x plus 4x makes 6x minus 20. All right, I'm going to add 20 to both sides. Slide up just a touch. All right, so 6x equals 28 plus 20 makes 48. Dividing both sides by 6, and I'm getting x equals 8. So as an ordered pair here for my solution, I know x is equal to 8. Great, fine, dandy. Now I need to figure out y is. So you're going to substitute again this value we just found for x into either of the two original equations. Which one? Doesn't matter. I'm going to pick the one that I find easiest, which generally tends to be the one where the variable is already solved for, but it doesn't actually make a mathematical bit of difference. So x is going to get replaced, and there's a minus 5. So if I replace x with 8, y is equal to, well, 8 minus 5 makes 3. And so I am getting a solution point of the 8 comma 3. And I like it. All right, so that is going to be the end of this video for a little bit more practice on solving systems of equations, specifically using substitution method. Let me know if you have any questions or concerns, and we'll see you in the next one.